There are a number of existing language use guidelines and tools that can help you improve your coding style. Perhaps the most famous is Misra C, which was originally developed for safety-critical automotive applications. There's also a C++ version of this language guideline. Misra C emphasizes the use of the C programming language in critical systems. This means that it intentionally makes the trade-off of eliminating some potentially useful language features to provide significantly reduced risk of defects. This means that it intentionally makes the trade-off of eliminating some potentially useful language features in exchange for reduced risk of defects. As an example, it forbids the use of recursion and dynamic memory management using calls such as malloc. While both of those techniques may be acceptable in non-critical desktop software, in embedded systems, these language features were deemed too dangerous to be acceptable. Misra C emphasizes code portability and avoiding high-risk language features. It also sets forth best practices for safety-critical software. It can improve the reliability of any C code, but is best used for mission-critical software that can live with more restrictive language use in return for improved software reliability. As this figure shows, the 2012 version of Misra C, with its security rule addendum, includes well over 100 rules, some of which are advisory, meaning they're nice to have, some of which are required, meaning that you need to do them but you can deviate if need be, and some of which are mandatory, which means you have to do them. Additionally, there are 17 directives that are generally not suitable for automated checking, but which are either advisory or required as well. Cert, which deals with security advisories, created a coding standard for C, C++, and Java to improve software security. An example rule would be that you are not allowed to use unbounded string operations because of the risk of buffer overflow. The Cert publications also include a list of tools and which coding rules they're able to check. In conforming to these guidelines, it's helpful to use tool support. Static analysis tools act more or less like compilers, but instead of generating code, they generate warnings. One type of especially useful warning is called a strong typing warning, which warns when variables which have the same underlying machine type have different meanings, such as feet versus meters. There are many static analysis tools, both commercial and free. If you want to get started, you can use GCC with a lot more warnings turned on than just WALL. You might think that -WALL generated the maximum possible warnings, but in fact, the set of warnings was frozen for compatibility reasons, and there are many, perhaps dozens of warnings past -WALL that you can turn on that can be very helpful. Dynamic analysis tools go beyond static warnings and instrument running programs to find problems at runtime. A classic example of dynamic analysis is looking for memory array bounds violations or resource exhaustion. A good starting point is the Valgrind toolset, which includes memory buffer checking. There are commercial tools as well as free tools for all of these functions, and the point of this discussion is not to recommend a particular tool, but rather to encourage you to look into tools that you will find useful for your particular situation and budget.